Hello, my name is Tom, and when working on Project Protas, I've been working as a user interface and user experience developer, as well as helping out on the documentation.
Hi, I'm Sam. I've been the project lead and I've been responsible for the overall direction of the project as well as working on multiple features.
My role within the project was being the 3D environment developer. This meant that I was in charge of developing the Unity scene. I created multiple assets within the project, including adversaries such as SAM turrets and missile engagement zones, models for bombs and projectiles, as well as working on the drone model and the surrounding terrain.
Hi, I'm Dan. In Project Protas, I've been responsible for the training of the drone and ensuring that the drone is able to solve whatever scenario is thrown at it.
To give a little background, mission planning systems are software that allow military aircraft routes and engagements to be planned in advance in a way that minimizes risk. Project Protas aims to build upon this software by using AI to help calculate the mission plan automatically. This could bring forward new strategies while reducing the time required to devise the mission plan.
We've delivered a proof of concept that is capable of using AI to calculate an optimal flight path for a user-specified mission. The AI trains itself on thousands of different randomly generated scenarios to make sure it has the prior experience to solve the scenario that you create for it.
The focus of Project Protas was using artificial intelligence to solve never-seen-before mission planning scenarios. To achieve this goal, it was vital to know how artificial intelligence works. For the AI to be able to solve scenarios, a neural network model must be trained. This model is trained from repeatedly running an AI agent through random scenarios and based on its actions in the scenario environment, giving the agent rewards. The agent links the rewards it gets with the observations it has made. When a good decision is made, the agent receives a higher reward. This allows the agent to learn what decisions to make in similar situations. For training the model, we used an on-policy, deep reinforcement learning algorithm called proximal policy optimization. There are two types of policy gradient algorithms, on-policy and off-policy. The key difference between these algorithms are that off-policy algorithms train the model no matter what an AI agent does, and will be able to solve scenarios once the algorithm has gathered enough data from the training environment. The main issue with this is that it is very slow. On-policy algorithms are a lot quicker, but the actions made during the training are much more important. Therefore, if you start with a complicated scenario, the algorithm may never solve the scenario. To get around this, we implemented curriculum training to train the agent. This is the process of starting out with an easy scenario and gradually building up the difficulty until it can solve any scenario it is given.
We integrated multiple processes into our workflow and refined them over time, which drastically reduced the number of mistakes we made as well as improving overall quality. At the end of every 2-week sprint, we did a retrospective to reflect on how we can improve for the next sprint and to highlight any outstanding user stories. We also chose to use a branching strategy known as trunking. This helped stop us from wasting time on huge branch mergers and helped ensure that we had a stable, up-to-date build at all times. Because we didn't have a separate development and release branch, it was vital that we ensured the quality of everything going into the master branch. This meant that we performed detailed code reviews and used static analyzers for every pull request into the master branch. We also set up a dashboard for every team member, which helped us see what work was scheduled to be done for a sprint and how our user story turnout rate was changing over time.
Part of the code quality controls we had in place for Project Protas was mandatory XML documentation for every public and protected object. This made it easy for another developer to look at a method and instantly understand what the method does and how to use the method's parameters. Also, as part of the build process, a website is automatically generated so all documentation can be viewed in one place.